Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a times of a is equals to a plus a plus a. A- And here we need to solve this problem for all the values of a. And at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And I hope so you like this method, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now first you see here in the left hand side, these are the two same terms are multiplied three times, and the exponent of all of these three terms are 1, and we use here the exponential line, and we can add the exponent of all of these terms, and we write in this way. Similarly, in the right hand side we need to take common a from here, and when we take common a we get the remaining values are 1 plus 1 plus 1. And now here further in the next step we need more simplifications, and in the left hand side we obtain a to the power of 3 is equals to, in the right hand side we have 1 plus 1 plus 1 becomes 3a. And further in the next step we move this 3a from right hand side to the left hand side, and it will becomes a cubed minus 3a, and this whole equation is equals to 0. And further you see here both of these two terms involve a, so that we take common a from here, and when we take common a we get the remaining values are a square minus 3, and this whole equation is equals to 0. And now in the next step we need to divide this equation into the two cases. The first case is we write a equals to 0, and the second case is we write a square minus 3 is equals to 0. So this is the first real root of the given equation, and from here we need to rewrite this equation as, we write this as a square minus, we write this 3 as square root of 3 and its whole square, and this whole equation is equals to 0. And here we use the nice algebraic formula. You know about that. If we have x square minus y square equals to x minus y times of x plus y. So according to this formula, you see here the base of this term is our x and the base of this term is our y. And now here we need to apply the quadratic, we apply this algebraic formula, and after using this formula to the above equation, it will be written as, first you have x minus y, the value of x is a minus the value of y is square root of 3, and the value of x is a plus the value of y is square root of 3, and this whole equation is equals to 0. And now here in the next step we need to break this equation into the two cases. The first case is we write a minus square root of 3 equals to 0, and the second case is we write a plus square root of 3, and this whole equation is equals to 0. So from here we easily get the value of a is equals to square root of 3. This is the second root, and from here we get the value of a is equals to minus square root of 3, and this is the third root of the given equation. So here we obtain these are the three roots of the given equation, okay, which we get here. So this is 0. So these are the three roots which we get here in this method. And now here in the next step we need to verify that which of these roots are solution and which of these roots are extraneous root. For this we need to verify the roots, and for verification we need to copy down given question statement. Here it is a times of a is equals to a plus a plus a. And here in this side we will be verify a is equals to square root of 3, and in this side we will be verify a is equals to minus square root of 3. So first we verify these two roots of the given equation. So now when you put this value on both of the sides, it will be written as square root of 3 multiplied by square root of 3 multiplied by square root of 3 is equals to square root of 3 plus square root of 3 plus square root of 3. And similarly in the same pattern we substitute the negative term here, and it will becomes minus square root of 3 multiplied by minus square root of 3 multiplied by minus square root of 3 is equals to, when you put this negative value here, it will becomes minus square root of 3 minus square root of 3 and minus square root of 3. And further in the next step, here we need more simplifications, and it will be written as So first we focus in the left hand side in the first case. So in this case, you see here, when we multiply this square root of 3 and this square root of 3, it will be written as square root of 3 and its whole square multiplied by square root of 3. This is third square root of 3. And here you see that these are the three same variable terms are added by each other, and we write it as 3 times of square root of 3. Here you see that this 2 and square root are gone, and we obtain 3 times of square root of 3 is equals to 3 times of square root of 3. This shows that both of the sides are equal. It means that the value of a equals to square root of 3 is satisfied our given question statement. And now here in the same pattern, we need to verify these values. And here you see that when we multiply, this is minus times minus becomes plus 1, and square root of 3 multiplied by square root of 3 becomes square root of 3, and its whole square is multiplied by minus square root of 3. And in the same pattern, when we sum up these three negative square root of 3, it will becomes here minus 3 times of square root of 3, and these 2 and square root are gone, and we obtain here minus 3 times of square root of 3 equals to minus 3 times of square root of 3. This shows that both of the sides are equal. It means that the above both values of a are satisfied our given question statement. And now here we need to verify the third value of a, and our third value of a is 0. So we substitute a equals to 0 in both of the sides of the given equation, and it will become 0 multiplied by 0 multiplied by 0 equals to 0 plus 0 plus 0. And here you see that clearly we get 0 equals to 0. So this shows that all the three roots of the given equation are satisfied our given question statement. And finally, we have the solution set of this problem is 0 and plus minus square root of 3. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.